Hi everyone, and thank you for your interest in CI Spark and joining us today for the live demo. So before we actually go through the demo and show CI Spark in action, I'd like to take a few minutes just to discuss or to talk about the main problem that we are addressing with CI Spark, which is the automatic generation of tests, or to be more precise, of fuzz tests. So if we take a look at the software landscape today, we see that modern software is getting increasingly more complex. And also the base in which we develop and deliver software is getting much more quicker. And so with DevOps, we build CI/CD pipelines that run automatic tests with each code change. And this enables us to check the quality and the correctness of our software with any code change that we do. And this enabled companies like Amazon to do to deploy to production very quickly. So in 2015, they were able to deploy 1 times per second, and the time or this deployment frequency has increased significantly until then. And it's these metrics, like how often you deploy and how often does it take for a code change to reach or to get into production, are some of the important metrics that distinguishes high performing development teams that all of us would like to have or be part of. And so but if we take one step back, this also includes both technical or functional tests and also security tests. But if we take one step back from this ideal scenario and take a look at how it's actually happening in the real world, let's say, we see that clearly that security testing can't keep up. And in a recent study that was published last year, it was found that almost 45% of software being released without going through proper security checks or security testing. And 34% of the security teams, they reported that they are unable to keep up with the release cadence. And 32% of developers mentioned that they skipped the security processes altogether. So this clearly demonstrates that a new testing strategy is needed to keep up with the base and in which software is being developed. And so if we take a look at the security testing, also we clearly see that white box dynamic testing, including feedback-based fuzzing, is currently the most effective approach to find bugs and security vulnerabilities in the software. And it's the self-learning AI that this technology uses to basically explore the program state and to generate test cases that maximize code coverage is what makes this very effective in automatically generated test cases that get very good code coverage. And so this has a very significant potential to help us with scaling the security testing. And so what we would get here, so if we go back then to our ideal scenario, so how security testing should be integrated into the development process. So it should be an integral part of the development process, but not an afterthought that's done only, for example, before releases. So how does this look like? So you always start with the developer. where you develop new features, you refactor your code, you fix some bugs. This gets then pushed to your continuous into your code hosting system, which triggers your CI/CD pipeline. If you get any issues, any security issues that with the automated tests with fuzz testing, you get to have a look at exactly what happened. So you see all the information that you need as a developer to fix the issue, including the stack traces and the exact input that triggered this bug. And this gives us as developers all the information we need to go through and debug what went wrong and fix the issue. And if we look at this whole process, so the only step that's not automated is with the developers, where the manpower is actually needed to have this mentioned DevOps, to have this extensive suite of tests, of automatic tests that give us this instant feedback if anything went wrong. And obviously, all development teams, they have very limited or very tight schedules, limited time and resources to invest into or the needed amount, the amount that they want in writing tests or also fuzz tests. So we mentioned fuzz testing or white box testing as currently the main effective or the most effective method in order to find bugs and security vulnerabilities. But in order to effectively use this method, you need to write what we call a fuzz test. And you can think of a fuzz test as similar to a unit test or integration test that you would write, but instead of having concrete inputs that you provide as a developer, you need to you get inputs automatically generated from the fuzzer. And so the steps that you would need in order to get high quality fuzz tests are, so you first need to see where are the security critical functions, or where are the entry points, the interfaces in your application that needs to be tested, where a user input is being fed. And this can be very challenging if you have a large code base. And the next step, after you have identified which functions, which APIs you want to test, is to actually come up with a valid sequences of APIs called in your test. So if you have a function, or if you have a code where you need to do some initialization first before you call your API, if you don't do this, if you miss this, then you would get a false positive, meaning a finding that's reported by fuzzing that doesn't happen in real life. So you need to come up with, or to know which are the valid sequences of function calls that you need to provide. And obviously, you also need to come up or to know what are the valid parameters, because each function is a parameter of a certain type, and you need to provide valid ones in order to get high quality fuzz tests that sort of simulates actual scenarios. And of course, you need to be aware of all the dependencies between those. So if a certain API is called with only under a certain condition, or if the return value of a previous one is in a given range, for example, you need to be aware of all these dependencies. And sort of in the fuzzing community, with the fuzzing experts, and also from our experience with users or customers, this investment represents sort of a high barrier to adopt the technology. So we get the feedback. It's a very good technology. We find a lot of bugs with it. So this is great, but we unfortunately don't have the resources or all the resources to invest in having this extensive suite of fuzz tests. And so this is sparked the idea of CI Spark, meaning that we thought about, okay, what can we do to automate this process? And so as we know, generative AI or language models, they have seen significant changes, improvements lately. And with tools like GitHub Autopilot, it was demonstrated by, so here we see Thomas Dohmke, the GitHub CEO, that you can basically use the Copilot to write the full snake game in less than 15 minutes. So this clearly also demonstrates the code analysis and generation capabilities of large language models. And this is basically what we started with CI Spark. So we said, okay, how can we use how can we leverage LLMs, large language models, to automate this step, to come up with sort of an AI powered assistant that guides you, or that basically being your testing copilot that you can use to generate high quality fast tests. And yeah, this is CI Spark. So it's our AI assistant for automatically generating fast tests. So what it can do for you at this point? So you can use it to automatically identify, we call the fuzzing candidates, and these are the entry points that or the security critical functions that you need to test. Of course, you can then, after having identified the candidates, you can use it to automatically generate the fast test. And very interestingly, it has an interactive mode where you can basically talk to the assistant to improve, to give tips, to improve the quality of your test, to give tips, to have to address more use cases, as you will see in the demo. And of course, you can use it to, if you already have tests, you can use it to improve this test to get more code coverage. And if you also, for example, have unit tests, which I think we all should have, these can be used. You can give it as an example also to get high quality fast tests. And we currently support C, C++, Java, JavaScript, and TypeScript. So for all of these languages, you can use CI Spark. And so now that we have seen what it can do, so let's see how can we use it with a real world example. So here, and then I hope that you can see my IDE well. So this is what we see here is in IntelliJ. It's an open source project called the JSON Sanitizer. And what does this project? What this project actually does is that you can take, as it's mentioned here in the README, you can take any content, and with the JSON Sanitizer, you get a valid JSON. So you have this guarantee. Any input that you feed, you get a valid JSON that you can use in your application. So this does some sanitizations and parsing, and obviously this is an interesting project. So if I want to sort of generate fast tests with it for CI onboard, for CI Spark, and so it has several sort of sub commands that you can invoke, but the interesting one is what you call full onboard. Is that here you start in an interactive mode, and you can interact with the assistant. So now, if I say full onboard, so what it does first is that it gives me an overview about the project and the security relevance of it, and if there are any potential security risks that I need to be aware of. So let's start this. So now we get what's the purpose of this project, and so as you mentioned here, it takes a JSON-like input and make it a valid JSON. So you have this functionality, and you get the core components, which is the JSON Sanitizer class, data handling. So yeah, so and the security importance. So you get with this information, the idea is that you can quickly get an overview about what does this project does, if what are the security risks, if there are any known issues that you should be aware of. And after this step, you can say, okay, I want to continue. And when we continue, we go into the step where CI Spark would give us candidates that should be fuzzed in this project. So if we do that, we see, okay, it's we have the sanitize function, and we know what are the parameters. And here there's also an explanation of what this function does and why it's an explanation. So why it's a good candidate. So why this should be fuzzed. So I can read here. Oh yeah, it's a good candidate for fuzzing because it directly interacts with user input and perform the sanitization. So this is the entry point of sort of user control data or attacker control data that I should be aware of. And yeah, and if you have a look at the code, so this function has two variants, one that also take an integer. So let's take the first one. So now, okay, I have the candidates. So these two should be fuzzed. And now I can say what I want to do next. So there are several things that you can do. But in our case, what's most important is that we want to generate a fuzz test or a harness. So I select that, and then I need to select which function or which of the candidates, the proposed candidates, need to be tested. So I'll take the first one, so the one that takes us an untrusted string and do some sanitization there. And when I click here, so CI Spark starts generating the fuzz test, and here it's a Java project. And so what we generate a fuzz test for that we can run with Jazzer, so with our fuzzer basically. And so what you see here is the amount of work that sort of that CI Spark took and saves me. So it knows how to import the needed stuff, so the needed annotations for my fuzz test. It knows how the fuzz tests should be built, so which parameters it take, and it knows how to interact with these parameters. So for example, we get what we call a fuzz data provider that helps us to consume or to get special inputs with certain types. So here what I'm saying is, so we're taking all the fuzzer generated input as a string and then feed it to the sanitize function. So this is a fuzz test that basically you can just write, that you can just save and run. But if we have a look, so we mentioned that we can also interact with the assistant for better quality. So if we scroll down a little bit here, we see in the README this interesting comment here. So the output will not contain the substring script. So usually, if you use this in an application, basically you can take this JSON input and then put it in your HTML file. And obviously, you don't want the input to contain such strings, because this would then or might cause or lead to a cross-site scripting vulnerability. So now I say, okay, I know this about the application. So now I can say, yeah, the sanitize output should not contain this substring, so the script tag, substring, as this might or can lead to a cross-site scripting vulnerability. And with this hint, then I get a refined version of the fuzz test. So here we see now that we imported that the CI Spark decided to import another class, which is a security issue, which is an exception that you can throw, and it added a check. So if the output, the one that I sent us, contains the script that I taught it about, it just throws a high security issues. This is some exceptions that are delivered with Jezzer. Well, okay, it understood what I wanted to say, but just now as a final refinement, just throwing an exception without the message might not be the best thing. So I can just tell him or tell it add a meaningful message to the thrown exception. Yep. So now I get sort of a more refined version of the fuzz test, and now this refined version would then we'll see the message right now. Okay. Now throwing a security issue saying the sanitized output contains script, which can lead to a cross-site vulnerability. And this is something that this hint I give it in one of my interaction with it, so it remembers it. So now our fuzz test looks actually good, and now I will be then ready to save it. So I want to save it, and all I have to do is then specify a path where I want to do that, and I will save it here near the normal tests. And yeah, this obviously should be named the class name to Java. And now we see here a new test file. And so this is the code that CI Spark generated for me. So this to show all the import. And now this takes us sort of to the next step of integration that we did with our fuzzer Jezzer. So what mentioned that we want fuzz tests, or we're not testing or fuzz testing to look for developers exactly as they would as unit tests. And what we see here is that now this fuzz testing that Jezzer provides is then interpreted by my IDE, which is the IntelliJ, as a G-unit test, basically, so that I can now click here and with all the integration of the that IntelliJ offers, again, run, debug, or do whatever my test test. So what I want to do now is to run the test. So I can run the test. This then starts my fuzz test, feeds the fuzzer generated input into the application, see if it can basically find anything. So now I can go and say run. And this now starts this tests, and yep, we find quickly find a bug. And in this case, so we received an assertion error, and obviously this is in this case, this is not the exception that I am interested in. So what I can do now is then say, I want to ignore these exceptions. So ignore this one in the test, because these can be exceptions that I am not very interested in. And now I get a new version of the test. And now we see it puts this in a try-catch, in a try-catch block, and ignore the assertion errors, basically. Now I can also go and save this one. And I want to put it also in the same place. And override my old test. Yes, I want to override it. And now I have a new one where the assertion errors are ignored. I can run that. Yeah, I got another one that I'm not interested in. So these sometimes you get like findings that you are not interested in. You can also say also ignore the because my goal in this test is to see if I can trigger a potential cross-site scripting vulnerability. Ignore in the test. And now I should get another version where both exceptions are ignored that I told it about. Okay, then now I can save that version. And yes, go there. Put it there as well. Yes, I want to override it. And now I see the adjusted one. Oh, I don't get the breakpoint. I just want to, yeah, it's running. Then we see that also we get increased coverage in this case. Yep. And let's see what give us right now. Yeah, now, okay, now after ignoring all the exceptions, and yeah, now we see, that actually the sort of the claim of the library here that the output does not contain this thing is not correct, because we have found an actual input, this one here, that if you feed it to the sanitize function, you get an output actually containing the script tag. And yeah, obviously, sometimes look, in the demo now, I had this exception to, for example, the assertion error for the first time, but I just ignored it. And now I have a good fuzz test that actually triggered the vulnerability. And by the way, this is, as I mentioned, this is a real-world software, a real-world Java package that we tested, and we found this bug. And this bug is actually a CVE that gets a score of 9.8, which is almost the highest one that you can get. The highest one is 10. So it took me now only a few iterations to give more hints to CI Spark to generate a test that actually can trigger this vulnerability. So it took me less than a few minutes. So this sort of shows the whole interaction. So how you start getting a high level idea about the application. Then you move to getting the candidate, the entry point. Then you select which one you want to test, and then you get a fast test. And in the interactive mode, you can just interact with the assistant, give it more hints, ask it questions to improve the quality of the tests that you have generated. At the end, you have a test that actually high quality and finds meaningful bugs. So our results with using CI Spark with our sort of project work, we've seen that with it, it enables us to achieve up to 15 times like 1,500% acceleration. So what project that used to take us days to set up properly, now we can do it in less than 3 hours, basically. And this also goes for complex projects. Oh yeah, that I showed. Okay. So the initial results are really very promising, but of course we plan further improvements for CS Spark to make it even better. So what you want to do is in the near future is to have a better, improved static analysis for candidate selection, so that you can get more good candidates for fuzz testing. And we want to be able to play around or to give the flexibility of using different large language model as a backend. And yeah, of course, so relying on existing models is a very good start, and it really yields good results. But we plan also to fine tune own models, basically, or existing ones, to optimize or to fine tune it for the specific tasks of generating high quality fuzz tests. And this would enable CI Spark to work completely on premise in an offline mode, where that's basically then anyone would be able to use it without having to sort of share any information or any potentially sensitive information with a third-party provider. And yeah, I want to make it possible to automatically validate the generated fuzz test, because sometimes you might get certain errors so that your code will not be compiled, will not run fine. We want to automatically validate those. And yeah, of course, supports for other programming languages and test frameworks. Yeah, so with that, I almost some takeaways. So we, at the end of this demo, I hope I was been able to show that self-learning AI is currently the most effective method to find bugs and security vulnerabilities, and it's most effective when it's done automatically, meaning that you can get instant feedback about anything that goes wrong, and shown that with CI Spark, you can use it as an assistant to efficiently, quickly develop high quality tests. And of course, yeah, so we would like to get feedback about CI Spark. We want to improve it further. We want to work together with users to use their feedback to make it even more powerful. And for that, so we will be organizing yeah, an early access for it, and basically anyone, yeah, unless you're willing to basically opt out, you will be the first on this waiting list for early access. And for that, we look forward to your feedback, things that doesn't go wrong, that doesn't go as good, so that we can continuously fix that. And yeah, so that thank you for your attention, for your interest, and let's see if we have questions. Okay. Yeah, one question is that yeah, that's very impressive. One of the problems of LLMs is that they're limited context size for doing analysis. Is there any limit size of the code base that you can use in CI Spark for analysis and harness generation? And how do you deal with context size of large limit for large projects? It's a very good question. The idea is that you don't need the full source code of a project to generate high quality tests. And you can compare this with what you would do as as a human, basically. Local context is in most cases more than enough, meaning that if you see like how your in a local context, how your method or your API is used in a unit test, for example, or how is it called, then this is information is usually enough to generate high quality tests. And this is what we do, is that for generating the fuzz test, we don't put the whole source code obviously in the prompt, but we do our analysis to selectively sort of extract the information that is needed for this use case. And as I mentioned, there is one feature I haven't shown in the demo, which is you can give CI Spark a path to a file that containing some unit tests, and it will use this for in the prompt as well. But as I mentioned, you don't need the full source code, and this usually fits very fine. So all the experiments that we did, even with complex projects with large code bases, having this local context was more than enough to show the LLM's examples how basically this API is used. This looks promising. Can this generate tests fully automated without human action? Yes, in a sense, meaning we have a mode. What we shown was the interactive mode. So we have a non-interactive mode where you basically can do all this in an automated way. And I mentioned the automation frameworks. With that, what we want to achieve later is that you can just let the assistant, CI Spark, generate some fuzz test. You can try to run this fuzz test using the evaluation framework. If we encounter any build errors, the plan is if we encounter any build errors, is that this will also be then used for the LLM to refine the fuzz test. So usually build errors get useful insight about what went wrong. And also, if you don't see that code coverage is increasing in an expected manner, you can also use this in a feedback loop so that you can iteratively generate high quality fuzz tests in a fully automated way. So this is what you want to achieve with the evaluation framework. Okay. So I don't think we have further questions. Yeah. So thank you very, very much for your attendance, for your interest in CI Spark. And yeah, if you have other questions offline, you can contact me via email. I'm also available on Twitter or LinkedIn. So we'll be happy to talk to you. And I look forward to your feedback in the early access phase. So thank you very much. Bye-bye.